We have seen how to produce web pages locally on our file system that we can load. But what we would really like to do is build servers that can serve web pages to the whole internet. So let's take a look first at what happens when you get a page. So suppose I type here https soe.ucsc.edu, which is the site of my School of Engineering. You do this, I'm now sitting at home actually, and if you do this, I get the page. So how does this work? Well, let's see a moment. So here is my School of Engineering, suppose, in a node of the internet. The internet has nodes all over the place. And here is my house, okay, with me sitting in it recording this video right now. And the internet has, maybe I'm linked to only one local node, but then the internet has a complicated structure to be redundant and accommodate large traffic. So maybe these nodes are connected in some complicated way. Certainly my School of Engineering is connected to more than one node. Okay. And so if I do a request for a page from home, I have to somehow find a path, maybe not the shortest, but the best from the point of view of traffic, that actually connects me to the School of Engineering to get the page, because the page of the School of Engineering is sitting in a server located there actually. So how does this work? Well, here I ask for essentially, here I ask essentially for www.soe.ucsc.edu, okay, which is my page. But for a historical reason predominantly, the internet is not able to take a string and figure out where the string is in a single step. The packets that flow on the internet actually will have to contain an IP address, which is a string of numbers. The most common ones are the old ones, the IPv4, which are a string of 4 bytes. My School of Engineering will be 128, 128, and then I forgot, but we can look it up in a moment, but suppose it is 106.27. There will be some number like this. So the first thing we need to do is go from the name of the School of Engineering to its IP address. Once we have an IP address, there can be a request routed on the network for that address. And I want to show you how the process of going from name to address works, because if you need to configure your own web server, this is important. You will have to essentially have a name for your web server and make sure that the requests for that name are directed to your IP address of your server. So this process is called DNS. I cannot write there. DNS. Well, I still cannot write here. Okay. And it's the domain name service. Okay. And I want to show it to you simply very briefly in action, how this resolution works, and comment on it a little bit. Sorry. So, suppose I want to know what is the domain name associated with www.soe.ucsc.edu. How do I do it? I can do this, the browser does automatically, but if you want to do it by hand and see the whole story of it, you can do dig plus trace of this. Dig is a command that you can find on Linux and Mac. I'm not quite sure whether it's there on Windows, but you can search for the equivalent on Windows otherwise. So if you give this command, you get a super interesting trace out. So the search begins from the top. So I want to know about www.soe.ucsc.edu. So the first thing I do is I ask the gods of the internet, so the root servers of the internet precisely, for who knows about edu addresses. So the first thing I do is that I ask Google, just because I have 8888, which is a Google domain name server, for the address for who knows about edu addresses. So when you configure the network in your Mac or in your Windows laptop or in whatever you're gonna use, you need to configure the domain name server that you are going to use. This is the authority that you are gonna bag with your requests of translations from names to addresses. There are three that in particular I recommend. There are two Google ones that I use. They are 8888 and 4444. And there is also a Cloudflare one that is 1111. These, in my opinion, are the best domain name servers because they work incredibly well and they respect your privacy. I never would want to ask or to use directly my ISP's domain name servers because they occasionally play tricks with you. For example, they may trace which pages you visit, they may trace which queries you do. Sometimes when you ask for a page, they may even sometimes give you incorrect information. So I trust the Google and the Cloudflare ones above everything else. So in this case, the Google one told me, oh, okay, if you want information about anything, these are the root servers you need to ask. Okay, so then I ask one of these domain name servers at the top, and they tell me, oh, okay, for edu domain, you need to ask one of these education servers. I ask one of these education servers, and they tell me, okay, for ucsc.edu, the people who know, the servers who know about ucsc.edu are these ones. So there is one at Zocalo, which is a site in California. There is a couple of them at UCSC. So these are the domain name servers that know about all the machines at UCSC. And there is one at Zocalo. This is for redundancy. Universities host each other's domain name servers so that if the network of a university goes down, you still have other universities where the information is cached. Okay, so at this point, you ask these domains, please, what is SOE? Okay, and you receive this reply. That if you want to have information about SOE, you need to ask either these or that of the UCSC domains name servers or this other one, okay? No, sorry, these two, essentially, not this other one. Then you finally ask the last one, the last expert, you ask one of these ADNS2 we decided to ask, and this ADNS2 finally tells you, okay, www.soe.ucsc.edu is a nickname for SOE Virtual Machine VM SOE UCSC.edu, and SOE VM SOE.ucsc.edu is 128.114.47.214. Okay, so you essentially when you have an address like this, you take it apart and you start asking the top domain server for who knows about edu, and then you do all this chain. Now this chain of queries is not repeated all the time, it's cached at all levels. So typically when you look for the site of your School of Engineering, you have already done many queries to your university, and so for example, the servers that have to do with the ucsc.edu, you have them already cached in your local laptop, and so on and so forth, right? So you don't typically do this complete chain of authority, but this I wanted to show you how it works. Now, typically, when you want to serve a web page, what you do is that you either configure a server and you have its IP address, or else you host your page in the cloud. This is by far your most common thing to do. In which case, what you do is that you configure your web page to map to a nickname directly, to a C name. For example, if I do dig lucadealfaro.com, okay, lucadealfaro.com is actually a nickname of this master at this funny address at amplifyapp.com. Okay, my personal web page is served by AWS, and so I had to set up this CNAME. You know, I bought the domain dealfaro.com and I went to set up the CNAME from Luca at dealfaro.com to the CNAME that AWS gave me. And then again, the DNS service tells me that this master address name is mapped to 4 possible IP addresses. Okay, why 4? Well, if we go back to the notes, imagine that there is an enormous number of people that want to request my web page, which is extremely unlikely. But then there is the whole internet connected, and Amazon has apparently 4 front-end servers or IP addresses to which these requests can go. And so there are requests that can go here, can go here, or can go here, or can go there. Okay. Now, internally to Amazon, this is Amazon Web Services. These can be just front-end servers that have each one of them an IP address, but internally, each one of these can distribute the request to a very large number of internal servers. These would be, organized inside the Amazon cloud. But essentially, these 4 IP addresses that you see here are the 4 entry points to the Amazon cloud for this particular service that I'm used, which is called Amplify, that hosts your web pages. Okay. Now, one interesting problem that is worth mentioning is the following. Let's look at what happens again. So here is you with your laptop. Okay. This is a badly drawn laptop, and these, are other people's laptops. You are maybe sitting in a cafe or at an airport. So this is a Wi-Fi, access point, and then there is, the rest of the internet, and then at some point there are these domain name servers, DNS server. So when you ask for the site where you want to go, you may want to go to bbc.co.uk, no? So this is the website of the BBC. And you need to ask essentially and send out this information, where is the BBC? And this will give you as answer back an IP address. Now, the interesting thing is that these DNS queries are typically not encrypted in the default protocol. Okay, so other people who listen to the same Wi-Fi can perfectly well know which sites you are visiting, including people on the same wireless network, so people sitting next to you at the airport, and also people that have access to this communication. For example, the ISP from which the airport or you, if you are at home, are buying the bandwidth. So, for example, my ISP knows typically all the sites I'm visiting. And I'm, a useless academic, I guess. But suppose I work for a company called, New Ventures, that is trying to do mergers and acquisitions. And you see me visiting the sites all the time, because you see it from the DNS of Company A and Company B. And Company A and Company B, I started visiting them at the same time last week. Then maybe if you are my ISP, you can start thinking, that's pretty interesting. Is a merger between Company A and Company B in the works? No? I mean, the information about which sites I visit can tell you quite a bit about the kind of work I do. And if my work had value, you could, infer something about what is going to happen maybe in technology or in finance or in other fields. Another important use of the data could be aggregated use. Suppose you are an ISP that has a lot of customers in California. Then you can see quite precisely how often these people access those sites because of the DNS queries. And so you can decide in which companies you yourself invest your money. You are going to invest money in companies whose usage is increasing. Notice that this does not depend on the connection you have to the particular company. Maybe you use HTTPS to connect to a particular company. So the information you communicate to that company or to that website is private. But the fact that you are interested in that website is typically not. and may have, especially in aggregate, a huge economic value that you are essentially leaking to the ISP. And this also means, among other consequences, that if you play the stock market, or if you want to invest, or if you want to use your brain to decide what are the technology directions of the future, these ISPs, by collecting the aggregate information of you and others, have an advantage over you. Okay? And so this is important to know. And lately, there are some services that try to actually hide the DNS activity. The problem is that that try to hide it via encryption. So they try to essentially encrypt, okay, this channel, this query from you to the DNS server. And they encrypt it by making it pass essentially through, for instance, the HTTPS protocol. The point is that this is not standard. So your laptop, for example, does not, in a standard way, encrypt the DNS queries. That I know, so far, there are only 2 browsers that support this hiding of resources, and they are Mozilla and Chrome. For both Mozilla and Chrome, you can set up the encrypted DNS queries so that nobody can spy on the sites you visit. But the only glitch or problem or feature, or I don't know how you want to call it, is that the destination DNS server needs to support that protocol. And so far there is essentially only 1111 as DNS server, which is the Cloudflare one, and a couple of other ones. I think the ones by Google also support it in part. So this is an area in which there is a change that is happening rapidly, and the goal would be to prevent essentially ISPs and snoopers on your network from collecting information about what sites people are visiting. Okay. The last thing I want to tell you is about ports. So when you do a request for say www site.com is an imaginary address. So your connection goes to a computer. So this is actually the computer, the host. And the host has many so-called ports. So there is one physical connection to the network that has an IP address. But on the computer side, there are many so-called ports that are logical places inside the computer operating system where the network communication can end up. And they are numbered from 1 to 65,000 and something, which is 2 to the 16. Okay? Now, typically web requests, if you don't say anything, they go to port 80, which is the classical port for HTTP. HTTPS requests go to port, sorry, let me draw it this way, 443, which is called the SSL port for the encrypted protocol that HTTPS uses. Okay? You can cause requests to go to any other port. For example, if you ask for www.com and then you say .8000, this request will actually go to port 8000. Okay? So our job internally now, that we will do from the next lecture on, is to figure out, if I get an HTTP request on a certain port, how do I configure my web server so that it can produce a reply and send it to that port? So I want to listen to the request from that port and send a reply to that port as well. Okay? And this will be done with the help of course, Py4Web, our web framework.